All right. We're going to go ahead and go through these. So what I'll do is I'll write just the answer. Y'all with me? I'm going to write just the answer, and then the ones that you guys struggle with or you'd like clarification for, we'll do the whole process, okay? Okay? Are y'all with me? All right, here's the first one's answer. If you don't understand it, then we'll talk through the process. It had a GCF, P, and it factored down to P plus 12 times P minus 7. We good with that? Nobody needs that one done. Okay, let's flip over to the back. Now remember, if your factors are not the same as mine, they don't all have to be in the exact same order, but if you don't have the same factors that I have, then you didn't go far enough or you didn't do it right. One of the two. So here's what you should have gotten on number 15. Again, I'll go through the answer, and if you have a question, we'll go back through the process. You should have gotten W squared plus 2, and you should have gotten W plus 4 times W minus 4. That's the final answer. So do this one. Okay, so here we go. First things first. I want to talk you guys through the process again because I feel like that's important, the process. So when you see this particular problem, I hope that you recognize immediately there's 1, 2, 3 terms. 3 terms. Okay? We've only talked about factoring 3 terms in 2 ways. One, GCF, which we always check first. Guys, can I pull something out of W to the 4th, 14W squared, and 32? Definitely not. So there's no GCF. The only other way we've talked about factoring these is into 2 binomials. So we do that. I get my 2 binomials ready, and here's my process. I say, all right, what multiplies by itself to get W to the 4th? So I put W squared times W squared, right? Then I say, all right, what multiplies to get a negative at the end? It's got to be a plus and a minus, right, y'all? Got to be opposite. So that tells me I'm looking for 2 numbers that will multiply to get 32 right here. But because those signs are opposite, they have a difference of 14. It's got to be 16 and 2. It's got to be. There's no other option that will multiply to get 32 and have a difference of 14. So the last thing we look at is what sign dominated the middle right here? Negative. So that tells me negative has to go with the bigger factor. Which one's bigger, 2 or 16? So it's got to be minus 16. It's got to be plus 2. Now, some of you guys may have gotten to that point and maybe even left it here. And I get it, but that's not where we stop. It's not where we stop because this and this are both perfect squares, and the sign in between is a negative, minus, difference. This is difference of squares. Now, this one is clearly not difference of squares because that's a plus sign, and 2 is not a perfect square. So that one just comes on down. It's done. You can't do anything with it. It's not sum of cubes. It's definitely not difference of squares. So we can't factor it any further. So the W squared minus 16, though, can. So as we've been talking, and we've done this for a while, it's the one time a binomial will factor into 2 binomials. So all I have to do is say, all right, hey, what multiplies by itself to get W squared? W and W. What multiplies by itself to get 16? 4 and 4. And then what's the rule on difference of squares? One's plus, one's minus. So there it is. W squared plus 2 times W plus 4 times W minus 4. Okay? Do y'all understand that now? A little better? Okay, 17. The answer on 17 was 2a times a plus 8 times a plus 6. No, you could have put a plus 6 first and then a plus 8 second. That is perfectly fine as long as those are your correct factors. Okay, how do we feel about this one? No? You don't feel about it? You want me to do it? Okay, so here we go. Number 17. 1, 2, 3 terms. We've only factored those in what ways? Guys? In what ways have we factored 3 terms? Either 2 binomials or greatest common factor, which is where we need to start, right? So can I pull something out of 2, 28, and 96? Well, I definitely can pull out a 2. But we also have a cubed, a squared, and an a. So we can pull out 2a. Does everybody see that? You got to start with the GCF if there is one. And there was. 2a. So 2 divided by 2 cancels. It's a 1, right? A cubed divided by a to the first is a squared. So that first term, I'm left with a squared. Second term. What's 28 divided by 2? 14. And then what's a squared divided by a to the first? So that's just plus 14a. Now let's go to the last one. What's positive 96 divided by 2? Positive 48. And then, of course, what happens to a divided by a? It cancels. Well, it becomes a 1, right? It becomes a 1. So, there we have it. So I'm going to factor this, okay? So, ignoring what we've done here on the bottom, let me start over. The 2a drops down. But like Dylan said a second ago, the other method of factoring a trinomial is into 2 binomials. So my process goes like this. What multiplies by itself to get a squared? So we got a and a. What multiplies to get a positive? What are my options? How do I know which one it is? The middle sign tells me they're both going to be positive. Which also tells me that whatever 2 numbers I pick, they have to multiply to get 48, but those same 2 numbers have to combine to get, so what does that? What multiplies to get 48 combines to get 14? 6 and 8. 6 times 8 is 48. 6 plus 8 is 14. So it doesn't matter where I put them. Doesn't matter. So my 2 factors, or my 3 factors, are 2a, a plus 6, and a plus 8. What do you think? Good? All right, probably the most intense one you guys even had, whether you realize it or not, was number 19. Here's what you should have gotten. You should have gotten m squared times m squared plus 2 times m plus 3 times m minus 3. Quite a bit going on here, huh? There was a GCF. We factored a trinomial into 2 binomials. And then we factored a binomial into 2 binomials. A lot going on. How do y'all feel about this one? Thumbs up? So-so? Do I need to do it? All right, let's knock it out. Number 19. Again, when I look at this thing, I immediately see 3 terms. 1, 2, 3 terms. I always ask myself the same question first. Remind me, what is that? Yes. Is there a greatest common factor? Can I pull something out of M6, M4, M2? M squared. So let's do it. Let's pull m squared out of m to the 6th first. What's m to the 6th divided by m squared? 6 minus 2? m to the fourth. Then this minus 7 is going to come on down. And what's m to the fourth divided by m squared? M squared. Then this minus 18 is going to come on down. And what's m squared divided by m squared? All right. So I'm going to now try to take this trinomial and factor it into two binomials. What multiplies by itself to get m to the fourth? So we got m squared and m squared. What multiplies to get a negative? Positive and a negative. So we're asking this question. What multiplies to get 18 has a difference of 7? Yes. 9 and 2. 9 and 2. Right? It has to be 9 and 2. Last thing. What dominated the middle? Minus. It has to go with my bigger factor. Which one's bigger, 9 or 2? So minus 9 plus 2. Now, usually we're done at this point, but are we? No. And it's not because of the m squared. It's also not because of the m squared plus 2. Look, that's a square, y'all. If it's a square, the only way we can break down a binomial is difference of squares. So m squared plus 2 drops down. But what do y'all notice about this last one? Difference, see? Difference of perfect squares. So it's the one time a binomial breaks down into two binomials. And all you have to answer is this. What will multiply by itself to get m squared? M and m. What will multiply by itself to get 9? 3 and 3. And what's the rule on difference of squares? Done. Pretty intense, right? Had quite a bit going on. Hopefully you guys understand it better. All right, here we go. Number 21. Here was your final answer on 21. You had to do a little over-under action. But when you did the over-under action, you still were left with squares. So this is what it ended up being at the end. It was 2c squared plus 3 times 2c plus 1 times 2c minus 1. What do you think? Did y'all do good on that one? Everybody? You got stuck right before it? You got to 2c squared plus 3 times 4c squared minus 1? That's where you got? Okay. Do I need to do this one? Anybody? Yes? Okay. It's like y'all want me to stop talking and that's why y'all don't want me to do it. Because I see a lot of faces like, who's going to say it? Who's going to make us have to hear him explain another problem? Blake was like turning around with a threatening look like if somebody speaks up right now, he's going to come back and whip some tail. See it? You see it? All right. So here's my process. 1, 2, 3 terms. What do we always ask? Is there a GCF? No, I can't pull a number out of 8, 10, and 3. Okay, 8 and 10, I thought, well, maybe 2. Well, 2 won't go into 3. And then also, what does 3 not have? It doesn't have a variable with an exponent. It doesn't have a variable. I can't pull a variable out. So, no GCF. So when I look at this problem, and I know I need to take it down into two binomials, I recognize that A is not 1. Right? It's not 1. It's an 8. So what method am I going to use to factor? The over, under. So c to the fourth plus 10c squared drops down. And what is 8 times negative 3? So let's factor this. Ready? Into two binomials. What multiplies by itself to get c to the fourth? What multiplies to get a negative? So we're looking for the two numbers that multiply to get 24, but because those signs are opposite, have a difference of what? 10. What multiplies to get 24 has a difference of 10? 6 and 4 have a difference of 2. Remember, it's not a combination of 10, it's a difference of 10. Did y'all hear that? That's a very easy mistake to make here, because 6 and 4 combine to get 10. So those look great, but our signs are opposite. Has to be a difference of 10. 12 and 2. It's got to be 12 and 2. But see, that's a common mistake that you might see right there. Now, last thing, and then we can go a step further. What sign dominated the middle? So plus has to go with the bigger factor. Which one's bigger, 12 or 2? So plus 12 minus 2. Now, if you stop here, you did the over and forgot to do the under. Under with what number? And if it will reduce, we're supposed to reduce it. Will 12 over 8 reduce? What to? What will 12 over 8 reduce to? Nuh-uh. Yes, I'm sorry. I misunderstood. 3 halves. My fault. And will 2 over 8 reduce? What to? 1 over 4. Okay, so look. Remember how this works? What do we do with that denominator, that 2 right here? You put it with the c squared, and then it's plus the numerator, 3. We do the same thing on the right. What's the denominator? 4 goes with the c squared, and then minus the numerator, 1. And again, if you got to this point, you did a lot of great work. A lot of great work. I'm very pleased with this. But don't forget, what? What do we have? We have difference of two perfect squares. Right there. So that's the one time a binomial will do what? It'll turn into two binomials. And all we got to answer is this. What multiplies by itself to get 4c squared? 2c. What multiplies by itself to get a 1? 1. And what's the rule of difference of squares? Now we're done. Again, pretty intense. We had to use over under. Then we had to use difference of squares. Okay? All right, last two. Number 23. Again, I'll write the answer, the full answer, and then if you have a question, we'll go over it. Ready? On number 23, the total answer, the last thing you should have gotten is r plus 1 times r minus 1 times 4r minus 3. How did we do there? Claire? What? How did we do? Yes, ma'am.
How are you supposed to do it with 4 terms?
Oh, that's right. You weren't here. Was anyone else not here yesterday? Besides, okay, Carrie. All right. We definitely need to do one of these two. And we can do both because it's fine. Hey, stop that head shaking. We'll do at least one, and then we'll let the two people who weren't here yesterday determine whether or not we do the other one. So look at this. Let's go through the process. And the first thing I hope you guys recognize is there is 1, 2, 3, 4 terms. There's not 3 terms. There's not 2. There's 4 terms. Still ask the same question. Is there a greatest common factor? Can I pull anything out of 4, 3, 4, and 3? No, I can't pull a variable out because what does 3 not have? Doesn't have a variable. Can't pull out something it doesn't have. So, 4 terms, no GCF. We're going to factor by grouping. You group the first 2, pair. You group the second 2, because it is in standard form. Now, I look at this first group, and I pull out a GCF. Autumn, what can I pull out of 4r cubed and negative 3r squared? So out of that first group, I'm pulling out r squared. So just out of that first group, what is 4r cubed divided by r squared? 4r. And what's negative 3r squared divided by r squared? Minus 3. Now, we go to the second group, and whatever that sign is that's leading off, you have to use it. Now, I can see some people getting confused with this problem, because what can I pull out of 4r and 3? I can't pull anything out, is what most of the time people say. Who said 1? James? He's right. We got to have something. We've got that minus sign. There has to be a number there. Well, that's exactly the only value that's common to both of these terms is 1. So we're pulling out a negative 1. Now, what is negative 4r divided by negative 1? What will the negatives do to each other? So it'll become a positive 4r. What is positive 3 divided by negative 1? Negative 3. Now, somebody tell Carrie and Autumn why we know we can factor this problem at this point. We just factored it, but how do we know that this could be factored? That's right. The values that we have in here are the same. That's how we know. 4r minus 3 matches 4r minus 3. Y'all see that? You guys who weren't here yesterday? Now, here's the last thing. My factors then include, what did I pull out of both? What did I pull out of that first group? R squared. What did I pull out of that second group? Minus 1. There's one of my factors. One of my factors is what I pulled out. The other factor, what was left inside? 4r minus 3. That's why those have to be identical, because that second factor has to be those, and if they're not the same, it can't have been factored. Now, as you can see, we go one more step, because what is r squared minus 1? That's difference of squares, which will break down into 2 binomials. R times r, 1 times 1, plus minus. But the 4r minus 3 drops straight down. What do y'all think? You guys who weren't here yesterday, y'all understand that? So here's the very last problem, number 25. Wasn't too bad, because after you factored by grouping, it couldn't go any further. Here's what it was. It was 3n squared minus 5, and it was 5n minus 2. Couldn't take that any further, because these are definitely not perfect squares. Nothing multiplies by itself to get 3n squared. Okay?
So if it was not, then they can't factor, they just say.
They just stay. Yep, if that's not difference of perfect squares, it just stays. Okay? Questions? That was your assignment, okay? Now, everybody listen. I'm talking to y'all, I'm talking to the camera, because fourth period won't have me today. So, what I've decided is I'm going to give you guys a review over all the factoring, another day to kind of make sure you're right with this stuff, okay? Tomorrow, like I told you, if you choose tomorrow, you will have an opportunity to do corrections, okay, if you choose. for tests or quizzes that you've done in here. If you have missed a quiz or a test, you need to be prepared to take that tomorrow. The test, unfortunately, I didn't post it. I'll post it tonight. I have it done. It's graded. It was one you guys took a couple of weeks ago. Anyways, the point is, that's what we'll do tomorrow. I will also be giving you guys a review tomorrow, because I know you're going to want to study over the weekend, right? That's a joke. On Monday, we will review. Tuesday will be kind of like a second day of review. And the reason I say that is because there's some stuff going on Tuesday. There's going to be some juniors that are out of class time. But I'm not going to give a test on a day where a lot of people are absent. So our test will be on Wednesday of next week. Wednesday, okay? So you'll get a review on Friday. We'll go over it on Monday. Tuesday will be kind of like a, hey, you have an extra day to study in class. And then Wednesday we take the test. And I have to do that because I don't know exactly what the schedule are, but some people are missing Wednesday. And then Thursday, I think we're taking, isn't that day where you can miss?
Yeah.
And there's like ACT and there's a bunch of stuff going on next Thursday. That's why we need to get our test done before that. So, all right, any questions? All right, I'm going to pass out that review now. Or the sub will pass out that review now. And you have the rest of the class to work on it.